Hi, my name is Jonathan, and today I'm going to explain about kinematic one dimension. So this is for the physics 221, and the name of the professor is Azita Fadei from North Carolina College, and the date is 29 July 2019. Okay, so for the setup diagram, I'm gonna explain about motion kinematic one dimension, or you could say that it is motion in one dimension. And after that, in kinematic one dimension motion, there is a vector, I'm gonna explain about the introduction first, and then vector, and there's also the materials that I will use, the materials that I will use, and then there's also another explanation. And of course, FAT is a website or like simulation where you could experience about 1D motion. Okay, so for the purpose of this recording is to understand about the position, velocity, and acceleration, and also the relationship between three of them, and to understand about the graph between the position, velocity, and acceleration. Basically, it is also the relationship between the position, velocity, and acceleration. Okay, so the materials is just laptop, and then FAT is just the website, and this is actually the PowerPoint. I use PowerPoint to help me explain it. Okay, so for the introduction, kinematic is a word in the science to describe motion using graph, numbers, equation, etc. The motion, from what I know, the motion could be divided into two, one dimension and two dimension. But right now I just want to explain it to you about the one dimension. And then motion is also, the meaning of the motion itself is the change of position of an object with the interval of time. Okay, so first of all, to understand about the one dimension motion, we need to understand what is vector. Vector is basically a line where or a line which has the arrow and also the value, or you could say the value will be the magnitude, and this arrow will be the direction. So a vector need to have magnitude and direction. If it doesn't have that, I believe that will be the scalar, because from what I know, scalar is just a number, it's just a value. It doesn't have any direction. Okay, so first of all, in a one dimension motion, it has distance or displacement. In here I just said that distance is a scalar quantity and displacement is vector quantity. The difference between distance and displacement is just for distance. You could see that distance is, for this, the distance will be 4 times 2 times 4 times 2. And for displacement, the displacement will be 0, because if there is a person right here, then she will go back right here again, right? So the displacement will be 0. But if the displacement is here, right here, so the person walk from here to here, then you will need to calculate using trigonometry, 4 squared times 2 squared, and then take a square root of it. Yeah, that's just a difference between distance and displacement, but I believe distance and displacement is the first thing you need to understand, the first thing that you will learn when you are in a class about and the material, and it is about the one dimension motion. And so the next one will be the speed and velocity. The speed is the scalar quantity and velocity is vector quantity. Velocity is the rate of the change object with position. Okay, so the next one will be the acceleration. The acceleration is a vector quantity acceleration is the rate of change object in velocity. So basically this is the formula, and the relationship between distance, speed, and acceleration. I believe distance is equal to velocity times time, and to the relationship between the three of them is derivative, taking a derivative or integral. So to find velocity using distance, you need to take a derivative, like here you can see that RT, and then Vt equal to dr over dt. And to find velocity, you need to take a derivative. To find out acceleration, you need to take the derivative of the velocity, just like here. Okay, so for the integral part, it is the same, but just the opposite side. If you want to find this the velocity, just need to take the acceleration, the integral. Just take the integral of the equation of the acceleration. And it is also the same for distance. To find distance using speed, using the velocity, it's just taking the integral from the velocity. And right here you can see that velocity and speed is completely different. The velocity is the vector and speed is scalar, so speed is just like a number, like a value. But velocity, to know whether it is whether it is velocity or speed, velocity is basically you can see that it is a vector, so it must have direction, which is like an arrow, and it also must have like a magnitude, which is also like a value, but it is a thing like in a vector. In a vector thing, it's called magnitude. Okay, so this is the fat. You can see here. You can just using the whatever website you want to use, but I think fat is the best one. Okay, so you can use this just by yeah, so as you can see here, there's like a box here. There's also the person, and for this you don't need to see the force, just the speed and acceleration. So basically, as the speed will go up, the acceleration will also go up. Okay, so let's just try to push it. You can see here that if you want to try to play with it, you can just write fat and then should be right here, and then start play with simulations, and then choose physics, and then there's a lot of simulation if you want to play with it. But I believe this is the only one motion. I don't and it could be there are more, but maybe I'm not really sure if that is for the simulation for the one motion. Anyway, so the conclusion or summary for this video, it is about kinematic one-dimension motion, and we're talking about factors distance, displacement, speed and velocity, and acceleration, and also the relationship between three of them. So to find speed, velocity, to find the velocity, you need to take the derivative of the distance, or like delta delta distance, and then to take the acceleration, you need to take the derivative of the velocity as well. And if you want the opposite side, just use the integral. And maybe there's more if we also could use Desmos to prove the derivative side, I believe. Let's just say that the equation for the distance or like place position, let's just say it is y equal x squared plus 1 or just x squared, then the velocity must be 2x, right? Because yeah, you could see here it is actually more like plus c, but we don't know what c is, right? Oh wait, no, I'm sorry, I'm wrong. Yeah, so it should be like this. It shouldn't be like this, I believe, because the derivative should be so 2x. And let's just see. Yeah, it should be something around like this. 2x minus 1. I believe so. Let's just say plus 1. So this one. Yeah, it should be something like this. As you can see here, you could say that, let's just say the equation is x squared plus 1. Then if you take the derivative, it will be only 2x. I don't know about this part. It should be around. It should be minus c. Oh, sorry, like plus c. Yeah, it should be like this. Maybe I need to do research more about this, but no worries. Yeah, so basically that's it. Thank you for listening.